So today we're continuing to talk about how do you actually wire up a six-wheel chassis to use remote control drive using a FlySky drone controller and a CircuitPython microcontroller board on a six-wheeled chassis. This video is going to teach you all about doing the actual motor control and wiring the electronics on this part. So it'll teach you everything from getting your batteries all hooked up and anything else you're going to need to be able to get your motor controller running, as well as the code to get this thing driving around. So let's go get started. So let's get ready to actually wire this thing up so we can drive around with our remote. You're going to need a couple of things for the wiring. Of course, you're going to need your chassis. If you want to build this specific chassis, I've got a link in the tutorial, or a link to a tutorial to that in the description down below. You're going to want to get yourself a 2, 4, 6, 8, 10 piece of low U channel. You're going to need, of course, your FlySky receiver. You're going to need some sort of power switch and battery pack for actually controlling the motors. I'm going to use a 12-volt battery pack here. You're going to need a separate battery pack. I like to use 9-volt here for your microcontroller so you don't get any brownouts by using the same power supply for your motors as you do for your brain. You're going to need your battery tie-down strap, just a hunk of Velcro, your RoboClaw motor controller, and a couple Y splitting cables so that we can actually get our motors attached together. Of course, your harness here for your 9-volt battery pack so that we don't have things flying away, and a half pillow block for actually mounting this. And then a whole bunch of zap straps, cable ties, zip ties, whatever it is you want to call these guys. So let's get a nice clean surface here and let's get rocking. Our end goal is to have our battery in the middle and then all of our microelectronics hung up on one side of our controller here, with our micro boards and controllers up on one side so that we have our main axis to be able to build things off of later. We don't want to mount this in the middle, because we mount it in the middle, whenever you go to attach arms or anything else to our chassis, this is just going to end up being in the way. So we're going to put her off to the side. So let's go ahead and build this subsystem. Let's wire up our battery and our microcontroller on the same side here. So for my battery, I've got a link to this down in the description down below. If you want this, it just holds a nice 6 AA battery pack. I'm going to mount this one nice and low. And I'm going to go throw it through the second hole here. So I'll throw it through the bottom hole, and then I'm going to mount it through the second hole of my U channel. And I'm not going to tighten this one up all the way yet. Just get a little bit of tightness on that, because I'm going to have to put in at least 4. And if I put in too many, of course, I'm not going to be able to actually center this thing on. Sometimes, if you can't get that angle, I like to fold the cable tie as I bring it through, and that makes it easier for me to get those curves. You may find that a pair of pliers helps with being able to pull your cable tie through. So I'm kind of pulling these and wiggling them back and forth, and that gets it nice and tight. Give it a little wiggle test. Then we can grab our flush cutters. Go ahead and snap these off at the end. Let's put our microcontroller in up top. You want to leave a little bit of space up the top here so that we can put our radio receiver up top here. So again, let's get a couple zip ties. Find whatever holes you think will match nicely for getting that thing roughly centered. Most important thing is that you've got your barrel jack for your microcontroller close to the output for your DC motor there. So a little wiggle, and we've got that nice and stable. Near the top here, I'm going to put my other microcontroller, but I'm going to flip it around so that our power is going to be facing down, because we're going to have to route power to this eventually. And I'm going to throw some more zip ties here again. And I'm going to come in through the side here. So because I'm using the GoBilda motor, the GoBilda motor uses a bullet style connector, but we need to be able to connect it to our RoboClaw, which of course is a screw terminal. So I have these ring terminals here, and what these let us do is these allow us to clamp in nice and secure onto our terminals there. So I'll grab a number 1 Phillips, and I'm going to connect into my motor 2 and my motor 1 here. So I'm going to take out my motor 2 M2A and M2B section. And I'm going to actually just take this right out, push my screw terminal through my ring terminal, and then screw it right back on in place. This will just help get us set up for later and save us a little bit of time. Again, I'll take that out. Because you're going through your ring terminal, it's going to make your life a lot nicer, and you also don't need to overly torque these things. Now keep in mind, these terminals are reverse now. So because it's a DC motor, it doesn't actually matter which side is positive and which side is negative, but if you want your motors all spinning the same way, you should make sure that you reverse your motors here. Next thing I'm going to do before we mount this thing on is we need to get our little small pillow block on here. So I'm going to grab a couple 8mm screws, like so on the bottom, so that the bottom ends up being flush. Now again, make sure you're using an 8mm here. You don't want to go for anything longer. If you go for anything longer, you're going to start running into your other hole, which is going to be a pain when it comes to mount this later, so we don't want to do that. I'm going to try to mount it to about in line with this chassis point. Should make life a little easier to get in. So what I am going to do is I'm going to make sure that my microcontroller is facing to the inside of my robot. That's going to keep some of our wires out. So let's see. The goal here is to try to get not on this unit here, but on this unit there in line. So that's what we're going to try to get to. So we're going to try to line up those holes, and I'm going to have to tilt this thing up a bit. Get this and then change my camera angle. So we're going to try to get in right about here. And that's going to make life a lot easier because we're not going to be able to get in here because we've got a few screws in the way. So we're going to go up one higher. So let's grab our mix head here, come up by one, pick up our other end, line it up on the far side. And we should be able to thread in the bottom of that pillow block that we put in earlier. Just going to get this first one just a little bit hand tight, just snug, not crazy tight, because we're going to have to try to line up the second one, and if we tighten it up too much, you're going to have one heck of a time trying to line this up. Okay. And looks like I actually was able to line that up first try. That's nice. So now I can go ahead and snug this up a little bit more. Excellent. So we've got our motor control section on now. Then good for our electronics. Let's go ahead and put our batteries in place now. So we've got we've got a large Velcro strap and two little acetal ties here. And what these little acetal ties do is they just have a little cut through section that you can slide your Velcro part through. So we're going to mount these about here, roughly, about in the middle of our robot. So let's go ahead and get these on. You'll need a couple 12mm screws. Taking our Velcro strap, we want to take the sticky side down, go through, place our battery on top with the connector facing this way. We're going to pull it through, wrap around our loop, and then we should be able to pull down nice and taut onto that battery to hold that nice and secure in place. It's not going to be moving around on us. That's our goal, because obviously a battery that's flying around is not secure and not safe. We can also take our other 9-volt battery pack, add some Velcro straps on here to be able to hold your batteries in place. You don't want one of these batteries popping out and that depowering your microcontroller, because what's going to happen is your motors are going to run away on you without having that powered. Place it in like so, and we can wire that into our board. Make sure our DC jack is off currently. And then let's actually wire up the switch. This little guy here. I'm going to wire this switch up like so, just so I have nice, easy access to my power switch. I'm going to grab a couple 12mm screws here, again, with some washers. We can go ahead and wire up our battery now through our Tamiya connector, like so. And then one of these XT30 connectors can also go into your RoboClaw microcontroller. Plug that in. The other one we're going to save, because we're going to plug that onto a servo thing later, but it's nice to have an extra power when we need it. Now let's actually wire up our motor here. Now this is going to be the front of our rover. The motors here are going to be the back of our rover, and M2 is going to be the left side, and M1 is going to be the right side of the motor controller here. So M2 is going to be our left side. So let's make sure we do proper cable management so we don't actually run around things. Let's get rid of this Velcro strap here for now. Let's grab these two connectors here for our M1. And now is when we need our Y splitter. Our Y splitter is going to allow us to take that single output from the motor claw to be able to push out two. Now this is a 2 × 30 amp motor claw. RoboClaw motor controller. It's more than enough to be able to drive both of these DC motors. On the left side, we're going to make sure we do our red to red wire and black to black. So we've got our Y splitter on, and make sure when you connect these that you are grabbing by the plastic connectors, not by the wire, because it's a great way to pull the connectors off. Grab both these wires. It does not matter which motor goes into which, just as long as they're both going to the correct one. Again, we're going to go red to red, black to black. Same deal. Red to red, black to black. Set that one off to the side so we don't sort of tangle it up. Then we're going to grab with the M1 slot here, go into another Y splitter, but this time we're actually going to reverse our cables. So while last time we did red to red, we're actually going to do black to red, so that we reverse the direction of the DC motors on this side. Because of the way that our program is written, both motors take the exact same input signals. Instead of inversing the signal, we're inversing the current here. That's the nice thing about direct current motors, is that you can either send forward and reverse to these two, or you can send forward and forward commands and then just reverse the signal so that this one goes in the reverse direction. Now we're not going to reverse it on this side though, because otherwise we would cancel out the reverse that we just did. So again, we're going to go red to red and black to black. Make sure that at the end of your Y splitters, they are indeed red to red and black to black, because these are connected to the same gears. If they are opposing each other, you're going to end up causing some big problems for your robot. Let's do a little quick bit of cable management to get these things up and out of the way. And my favorite cable management tool at this point is actually not cable ties. Cable ties are a little too permanent. At this point, Velcro is your friend. And this stuff is awesome right now because we can actually hold these cables nice and secure away. A little bit of Velcro We don't have to worry about it getting in the way of anything. Now, as I'm tightening these up, one thing I'm making sure is that I'm not straining any of my cables here. I want to have a little bit of relief on these cables, because if I'm pulling really taut on them, it's going to provide some undue stress on these cables, which is not what you want. Last thing we need to wire up is our receiver, and, well, not even wire up, we need to mount this. I'm going to use a couple more cable ties on this one. Again, if you need the STL to figure out what this is, I've got a tutorial link down below. I'm going to go ahead and mount this one up like so, and I'm going to throw a few cable ties through. It's time to wire this thing up, and by wire up it means actually get it connected to our microcontroller. So we're going to wire up our RoboClaw first here, or sorry, a RoboClaw motor controller here first. We need 3 male to female wires here. The first one is going to connect to the S1 signal port, the top side, or the top mouse. The next one's going to connect to the S2. S1 is going to send signals to motor 1, S2 is going to send signals to motor 2. And then I also need to connect a ground. It does not matter which ground rail you choose. You can pick literally any one on this rail. Let's flip this around so we can look at our microcontroller. Now for my code, I have left pinned at D0 and right pinned at D1. So I'm going to grab my left here, bring it up and around to D0. My right, I actually need to get a much longer cable for that, and I need to get a much longer cable for that. Otherwise I'm going to get undue stress on those cables. So with that attached, last thing we can do is just wire up the receiver for our FlySky controller. In my case, channel 1 is brown, and on my pinout, that means that I need to go to 10 for that one. And we go ahead and route this on into 5 volts and ground. And orange is my 5 volt, at least on this one. Again, if you need a full wiring video on this FlySky, I already have a full wiring video down below. Now let's get these last few wires out of the way. So the very last thing I did is I just took the rest of these wires and just added up a Velcro cable here, so that we're not going to have these things flopping around as we start riding around. So if we were to test everything work, if we flick in our DC jack, we should have our microcontroller powering up. We can power that back down. Last thing we're going to do is we're going to check our motor controller is powered on. This thing might run away on you, so just be ready to turn this thing off right away. So we'll turn it on, and our lights are flicking on, so we're ready to rock. Turn it off. Let's go actually program this thing. So let's talk about what code you're going to need on your board here. All of the code that you're going to need, as well as all the libraries and modules, are in the description down below. You're going to need a few modules on your CircuitPy drive. You're going to need the RC library. You're also going to need the Arcade Drive DC library. So if I go into my Finder window on CircuitPy and go inside my lib folder, I have to make sure I have both the RC.py and Arcade Drive DC.py. Otherwise, this isn't going to work. Then we create a RC class with our channels 1 through 6 on channels D10 through D13. I'm not reading channels 3 and 4 because I'm not using the left and right controller in this. This is not going to be a full tutorial on how to use the RC module. If you'd like a tutorial on how to read the FlySky controller with CircuitPy, I've already got a tutorial on that down below. Then we create a new drive object. This is what actually makes our arcade drive work. Then inside of our while true loop, we read our spin, which is our left and right values here. We read our throttle, which is up or down. And if spin is not none and throttle is not none, that means we actually got a valid reading from these. We're actually going to output a arcade drive to our motors, as well as print those statements as to what those values are. The expected outcomes is 50 when it's in the middle, 100 when it's at the top, and 0 when it's at the bottom. Same thing here. It would be 50 in the middle, 0 when it's at the right, and 100 when it's at the far left. So 50 is your stop value in this respect because it's a scale from 0 to 100. So that's the main code. Let's go flash it on the microcontroller, save it over to a code.py file, and let's check to make sure that the expected outcomes are actually what it is we're seeing on our controller. I've got the code running on the microcontroller. I currently have the microcontroller turned on, connected via computer power. I have the main power shut off presently because this power switch is actually going to control the DC motor. So as long as this power switch is off, you've got no concerns that your motors are going to actually start running away on you. Another thing that I've done is I've lifted the whole chassis and drivetrain up onto a toolbox here. And what that's going to do is it's going to stop these wheels from catching and actually driving away on us, because you don't want to test this on a table, because if it goes the wrong direction or it goes a way that you wouldn't expect it to, you do not want your rover to be driving away off your table. So let's check our outputs on our computer. We want to check that as we move the joystick around, that our spin and throttle values are moving as we'd expect. So as I move around this second joystick, we should notice that our spin and throttle is changing as we would expect, high when we're forward and low. So we're actually getting correct values off of our spin and throttle. Let's go back and check now on our rover. So let's go ahead and flick on the main power. I'm going to check to make sure that my power cable is out of the way. I'm going to very slowly move the controller here. I'm going to check that both of the motors are moving in the direction you'd expect them to move. So as I move it forward, both of them should be moving forward. As I move it back, both should be moving back. And if I were to go a little faster, you get a nice smooth increase from 0 all the way down. And same thing, going in reverse, you should have a nice smooth in reverse and be able to get back down. Now we want to check that our lefts and rights work as we'd expect. So if we were to go left and just push left on the controller, we would expect that the right side should be moving forward and the left side should be moving backwards, which is what's happening. And if we were to do the other way around, we would expect it to rotate for us to pivot in place. So now that we've done our initial tests, we know that things are moving the direction that we want. Nothing's falling off, nothing's breaking, nothing looks like it's going to get in the way of wheels. We can power it down, and let's actually test this thing on the floor. So I hope that helped you with your robotics project and you're having fun driving around your RC rover. Last tip I'm going to give you: if anything goes wrong, make sure you shut off that power switch, especially that major 12-volt switch. That one is your master kill switch. So best of luck on your next robotics project.